start recording. So if you go to, I'll post it again. If you go to homework help, unless it's pinned. It's pinned. So if you go to homework help and check pinned, the most recent economics for engineers notes is there that I wrote. It hasn't been updated since a few hours ago. It has everything up to week 5, and including week 5 for Toxoy. It does not have week 6, which I will be working on in the next 2 days, and I will get a note for the next 2 days.
2 days cramming.
Yes, very much. So today I was thinking we finished the midterm. Let's finish the midterm that I started. Don't worry about Roblox. Thinking we finished the midterm that I started earlier today. If I can find it. Here it is. Yeah. And then there's only 2 more questions left in it, so we can do that. And then Toxoy did give out, I mean, it might not be worth the time for us to do it, but maybe, I don't know. Toxoy gave out that, it wasn't like a lecture this week, it was just practice problems, so maybe we could do the practice problems, and if we have trouble, look at his solution that he did. I don't know, maybe people like that idea. It's good to try to solve things yourself. So, but anyways, to begin with, we're going to start doing this. Oh, you know what?
That's from the midterm, right?
Let me fix something here. Yeah. Here. That should be good. I realized, because someone told me, my audio is very low in the recordings. So I think I brought it up now. Hopefully it's better. I don't know. We'll see. This is from the midterm. I think this is from Gervitz's midterm, but the chapter 3 and chapter 4 stuff are the same. So I have the solutions to this as well, by the way. Okay. So I'm going to get my notes open just so I have them. Good. Okay, suppose you purchase a new annual coupon bond for $1,000 face value. The bond has a 10% coupon rate and a 5-year maturity. Immediately after you receive your second coupon payment, you decide to sell the bond in the secondary market. The interest rate at the time of sale is 5%. What is the selling price of the bond at that time? Okay. So let's take a whatever called the cash flow diagram for this. What's happening here? So we have a bond, which we put $1,000 into at the start. Okay. Every year, so let's say years after this, 1, 2, 3, 4, 5. So it's 5-year maturity. Every year you get $100, 10% coupon rate. So you get 10% of the face value. Right, so every year you gain, right, $100, $100, but you only do it for immediately after you receive your second coupon payment. So we only do it for year 1 and year 2. You're projected to gain another set there, but not quite. So now we're saying how much can you sell it for? The interest rate at the time of sale is 8%. So essentially, what's left on the bond? We have another $100 payment, another $100 payment, another $1,100 payment. Right? So this is $100, $100, $1,100. The $1,000 and another $100 coupon payment. So essentially, I think we just have to get the present worth of those 3 cash flows at year 2, and we'll be good. So the present worth is and the interest rate is 8%. So interest rate is 8%. So the present worth of the $100. Sorry, that's not supposed to say. That's supposed to be 100 like that.
Wait, isn't that the nominal rate?
It is the nominal rate, and so yeah, that is the nominal. I'll call it IN, but just I. And then yeah, we will find the effective rate. Although since it doesn't actually say anything, we're just gonna assume that it's compounded yearly. So we're actually good. Yeah, an annual coupon bond. So yeah, we're good. This is the nominal rate. It's also the effective rate for this. So let's find the present worth of the $100, the $300 cash flows. So that's $100. P given A, 8% for 3 years. And then it's going to be plus $1,000. P given F, 8%, 1, 2, 3 years. And that should be right then. I don't know. Let's see. See if it works. 8%. So P given A 8% 3. P given A 8% 3 is 2.577. 2.577 plus 1,000. P given F 8% 3. P given F 8% 3 is 0.7938. 0.7938. 7938. Yep. And let's see if the math checks out. 100 times 2.577 plus 1,000 times 0.7938. I got 1,000. Present value is $1,051.5. So, A is my answer. And I will now check that. Yep, that is correct.
Wait, why'd you choose N to be 3?
Because this is the time of selling, right? So we're taking these 3 payments. So for this one, it's 3 because there's 3 payments of $100. And then for the $1,000, I want to go back 3 years to year 2. This is year 5. So I want to go back 3 years to year 2.
Okay.
Right? So yeah, my present worth is $1,051.50, and that matches the solution in here. So good. Okay, bonus question. What interest? Well, I may as well just put the picture on here. What interest rate makes? Oh, I should have my phone on. Sorry, I realize I'm kind of waiting.
Actually, can I ask a quick question?
Yeah.
Okay, so about the course conventions, because I always, for the first like 2 quizzes, I always like mess up the like what to round up and whatnot. So interest values that we get from like calculating I to like IM or IQ or I whatever, we should keep those to 4 significant digits while like any other. Yep.
Honestly, I really don't know the course convention thing that well. I don't like at all. So let's see what it is. Yeah, I did see an announcement, I think, for it, or maybe I'm imagining things.
Because I was also gonna ask you just now, did you like when you multiply? Did you multiply the 2.577 by the 100, and did you do that separately and then add them, or did you just put all of that in the calculator?
I just put that in one. I can put this in my calculator in one shot. I just did that in one shot there, right?
Okay.
Right. Yeah, and I guess 4 significant figures is enough because the tables are all in 4 significant figures. So I'd say just do everything in 4 significant figures, I guess.
Okay. Thank you.
Right. Yeah. No problem. I don't know if that's the right answer, but that's what I would do.
For interest is 4 6 eggs, but for the P of A 8% or 3 whatever, that's in 4 digits, 4 zeros.
Decimal places.
After. Yeah. Yep.
Okay. Thank you.
Okay, let's see this. What interest rate makes 1 million? Yes. What interest rate makes 1 million a year for 20 years, beginning of year payments? Oh, okay. Economically equivalent to 7 million upfront. What? 1 million a year for 20 years, economically equivalent to 7 million upfront. Okay. So, since it's beginning of year payments, let's actually start at year -1. What that makes, since we do that, I don't know if this is right, but this is what I'm going to do to start, is start at year -1, because then we can just treat it as if it's end of year payments. Right? Let me make the flow diagram so it looks like that approximately. So if we say this is year -1, this is year 0, 1, 2, 3, 18, 19, 20, right? So if I do this, then I can say, then I can just treat this as if it's end of year payments like normal, and we can do everything normally. So if we just say we're at -1. So what I want to do is every year I get $1 million, right? So essentially that is, I'm trying to find the value, the current worth, or what's it called? I forget the word now all of a sudden, but prime worth. That's not the word.
Principal
worth. Present worth. Yeah, present worth. There you go. Present worth. That's one. So at year -1, so all these are a linear series or a linear, no, is that a linear series? I don't know. It says constant payments. So I'm going to bring the present all the way here, like bring the worth all the way to -1. So the present worth is 1 million. P given A, some percent. We need to figure out what percent. Some percent for how many years? 20 years. And it's nicely just 20, even though it's the beginning of your payments because we're starting at year -1. Good. And then that'll be it. So remember, this is going to be at year -1. Okay, just to be clear, at year -1. So that'll be that present worth. And then I want the present worth of $7 million up front, right, to also be, let me see for a second, economically equivalent, 7 years up front. Yeah. So what's the present worth of $7 million up front? It is $7 million at year 0, but we want year -1. So the present worth of that is going to be $7 million. P given F, I 1 year. So bring it back 1 year to year -1. Then we equate these two, right? We equate 1 million P given A, I 20 equals 7 million P given F, I 1. Most of the zeros can cancel. In fact, that almost all can cancel. And now we plug in the formulas and solve for I think. Let's see. I need
Griffiths said it was best to like just guess. So like put in each of the percentages
just guess.
and see which side is equal to each. Because he said if you were like trying to, because it might be more complicated on the midterm, like actually putting in the formulas depending on.
Yeah, the formulas are usually very complicated.
Yeah. So he said like you could put like, since its range is like between 13 and 14, you could put like 13, and maybe you get, I don't know, maybe
so
on one side you
just
get
try
a
it
slightly
here.
bigger number. Yeah. I just keep trying until you get one of the percentages, and you can kind of like know, okay, it's between this and this.
Yeah, okay.
But what if
because
they didn't give you the multiple choice or the?
I think it will all be
choice?
multiple choice, but.
Oh yeah,
but if we didn't have it, yeah, that's a fair point. We'd have to actually solve. So let me just show quickly how you'd actually solve, and then I'll show you why it's very difficult to solve. So this is going to be 1 plus I. Why am I in green? 1 plus I to the power 20 minus 1 over I 1 plus I to the power 20. Sorry, that should have been 20. 7 times P given F is going to be 1 plus I to the power -1. P given F, yeah. And so essentially we just solve for I. Just the thing is that that's really hard to do. I don't see how to do it. Right? -1 over I 1 plus I to the power 20. Nothing changed there. I could rewrite this as 7 over 1 plus I. And then multiply both sides. So it'd be 1 plus I to the power 21 minus 1 plus I over I 1 plus I to the power 20 equals 7. And now I could FOIL this, binomial theorem it, and
isn't that a bit too complicated?
Yes, incredibly. It'll be huge, a huge amount of algebra.
You could just check the answer on Symbol app or something.
Yeah, but we're not allowed to do it on a test. So I think for the test, I think it's good to just plug in these values into this equation and see if you get something that's close to 7. Right? So let's try it 13. I don't know. Let's try 13. So it'll be, I'll take the equation.
Can we just plug it into the interest table? Because it's just P given A, right?
But it's I. We don't know the percentage.
No, like you can just assume the percentages, like either 13 or 14 or something.
Yeah, that's what he's
right?
trying to do.
Oh, that's easier. Yeah, that is easier.
Yeah.
Okay. You can either plug in the percentage values into here for I and see if you get close
Well,
to
you get the
7.
same thing,
wait,
right?
yeah.
Because those are just
Yeah. Exactly. Those are just-
pre-tabulated values.
Yeah. So sure, but let's do it like this. This is a little easier. It's more looking at tables. So we'll just take this, and we'll actually even just see if the ratio of, I'll just P given F I1. So P given F I1, and I'll see if the ratio is close to 7. So So I'll say try 13%. So I get P given A. What is 13%? 12%.
Sorry, why did we use P given F? In the one?
Because I'm trying to find the value at year -1.
Oh, okay.
Right?
Okay.
So I need to bring it back 1 year from,
Okay. got
Wait,
it.
wouldn't that be P given? Oh wait, no.
right? 7 million is the final. 7 million is the final here, which is the final compared to here, which would be the present. If we're
Okay.
saying present is -1, right, then it's 7 million up front. Okay, let's try. There is no 13% page on here.
In that case, wouldn't the 20 be 21?
The 20 would just be 20 because there's 20 payments from year 0 to year 20. That's why I started year -1, because we're doing 20 years of payments, but the beginning of year payments. That's why I moved to year -1. It's all beginning. If I said 21 payments, that means there would be an additional payment at year -1. And we're starting at year -2. But since it's 20 payments, the n is 20. I think. If I'm wrong, yes, that is a possibility that we could change and see. I don't really know what I'm doing that much, so yeah. Let's try. I don't have a 13%. So is there a 14%? There's a 15%. Okay, I guess I'll try 15% because that's the first one I can try. I'm actually just gonna have to use this. Yeah, sorry.
I have 13 or 14% and 15% on my tables.
Oh, okay. So could you tell them to me what it is? What's P given A, 13%?
P given A of 13% for 20 years is 7.0248.
So 7.0248. Okay, thank you.
Yep.
And then P given F, 13% 1 year. P given F, 13% 1 year.
Oh, for 1 year. Yes, sorry. P given. Oh wait. Oh yeah. P given F. Sorry.
Don't worry.
Given F. Present Warfel. Yeah. 0.8850.
50. Okay, let's see if this is close to. It won't be close to 7, so I can tell already. But 7.0248 over 0.885 is, I mean, kind of close to 7. It's 7.9, but I'm sure we can get closer than that. So 7.9. Okay, let's try. Can we try 14%? Is it okay if you tell me the number still, so that I
Oh yeah, no worries.
I don't have a 14%.
Yeah.
Yeah. So P given A,
So-
14% 20.
P given A. Yeah. Okay. P given A of 14% for 20 years is 6.6231.
Yeah.
And then P given F for 1 year is 0.8772.
0.8772. So 6.6231 over 0.8772. 7.55. So that's 7.55. And 15% I do have, so you're off the hook for this one. 15%. P given A, 15% 20. P given A, 15% 20 is 6.259. And P given F is 15% 1. P given F, 15% 1 is 0.8696. Oops, 8696. 0.8696. 6.259 over 0.8696 is 7.19. So we're getting closer. So I think that's a good sign that we're getting closer. Then the last one to check is 16. Do I have 16%? I do not. Do you have 16%?
Yes, I do. Yes, I do.
Thank you. So P given A 16% 20.
5.9288.
Right, it's 5.9288, and then P given F 16% 1.
0.8621.
Thank you. Let's see. 5.9288 over 0.8621 is 6.8. 6.8. So, since we were an overestimate for 15 and an underestimate for 16, I'd say the answer is somewhere between 15 and 16%, which gives us D. Let's see if that's the answer.
Could you quickly explain the whole ratio thing that you did there?
Yeah, let me just check if this is the answer quickly, and then yes. So yeah, that works. Okay, he doesn't really give the answer, but he did the same thing as us and then pointed to an arrow of where we got it. So yes, I'm pretty sure that means yes, the answer is right. Oh wait, yeah. It actually gives the answer in the front. Never mind. D is the answer. Correct. So what I was doing is I took the main economics part of this is this, setting up this equation, right? I should be clear. This is being multiplied here. Gotta answer the phone. Hold on. 1 second. We got Uber Eats, so it's coming. Okay. So this P given F I1 goes onto the 7 here. So this is the equation we came up with. I just found the present value of the two cash flows at year -1, right? And I use year -1 because this is beginning of year payment, so it's a little easier to do the linear series, right? So technically I could have done it a different way. That would have actually been easier, but okay, we're here now, so it's fine. So does this make sense setting up this equation, first of all? And then what I did with the ratio is essentially I turned this into this. I just divided both sides by P given F I1, right? And then I just found those values, and they should be equal to 7. They should be equal to 7. And
Wait, I have a question.
yes.
Is the 7 just supposed to be 7 million?
Yeah, because this was 1 million. And this was 7 million.
Okay.
So the millions
Okay,
just
okay.
cancel. So it's just 1 and 7.
Okay.
Right.
And how did you know that you want to take the 7 million back 1 year?
Because
to me it just seems like at year 0 that's basically the same thing.
the thing is that I know this present worth here is year -1. This present worth is year -1. And we say we get 7 million up front. That means year 0, we get 7 million. So I want to get the present worth at year -1. I want to bring it back 1 year.
Wait, how do you know that 1 million is year -1?
Because it's beginning of year payments. Beginning of year payments. What that means is that at year 0, we have a payment. The first payment is in year 1. Normally, you have end of year payments, which makes your first payment year 1.
Okay, got it.
So in order to be able to do that, I just said, okay, let's start at year -1 so that I can have end of year payments, and it'll be the same.
Makes sense.
No, you're trying to either keep it simple with 20 years, but couldn't, or like, I get the whole negative year and what you're doing. Could you also count like the 0 and be like 21 years? Is that also kind of like a different way that you could do it?
Count the 0 and say,
Because because a lot of questions they're asking, like, he deposits on the day like a kid is born, like which is technically beginning of the year.
yeah,
And then you count
but
the
that
year
wouldn't
0.
count. That would not count as a payment series, because the payment series has to start 1 year after when you start it. The first payment is a year after year 0, the upfront.
Okay.
year. So if this was just a normal payment series, there would be no payment on year 0, right? Because it's end of year payments, right? So if I say I'm paying $1 million every year, my first payment is in a year from now, right? But If it's beginning of year payments, then it's different. It's equivalent to saying we're starting at year -1 and we have end of year payments. Now, there are easier ways I could have done this. I realize I didn't do this the simplest way possible. There are easier ways that I could have done this. But this is what stood out to me. So, yeah. Does anybody want me to explain an easier way that I could have done that?
Sorry, I just had another question.
Mm-hmm.
If it was end of year payments, you wouldn't have to do anything to the 7 million, right?
Yes, you're right. If it was end of year payments, I would start everything at year 0, and 7 million would be the I keep forgetting the word, the principal.
Okay,
The
thank
present
you.
worth, yeah, no problem.
Sorry, can you go over the easier ways you could do it?
Yes, I'm pretty sure this will work. So I'm sure this what I did worked because I got the answer. But now the next part is I'm pretty sure this will work. Another way of thinking about this is instead of saying I'm making 20 payments of $1 million, let's say I'm making 19 payments of $1 million, and I have an upfront of $1 million. Okay, doing that, I get an upfront of $1 million plus 1 million P given A I 19. And this should be equivalent. One payment at the start of $1 million, and then 19 payments of $1 million after that. You have to treat it separately though. You can't just say this is 20, because then we'd be going to year 21. There'd be 20 payments until year 21. So it has to be 19. And I think that might be an easier way to think about it. You have an upfront payment of $1 million, and then, so forget the 7 million for a second. Upfront payment of $1 million, which I'll do in a different color. There you go. That's this. And then the rest of the payments are that. 19 of them between year 1 and 20 inclusive.
Do you change anything about the 7 million?
No, 7 million stays the same. Oh, sorry, never mind.
Okay.
Yes, no, I get rid of this. There's no P given F.
Okay.
There's no P given F.
Because you're considering both of them to be upfront, which is at year 0, right?
Yep.
Okay.
The
Gotcha.
first million is upfront. The first 7 million is upfront. The only thing that's not
Got it.
upfront is those 19 payments of $1 million. Again, this should be equivalent. I don't know, but this should be equivalent to what I did. But I will switch it back to what I wrote just because, in case people are looking at the thing after. So let me go back a little bit. Nope, that's as far as I can go back. Okay. So this is just 1 million. P given A I 20 at year -1, yeah, and year -1. Good. Okay. There we go. Okay, so that's this midterm. Okay, give me 1 second, guys. I gotta go downstairs for a second, and I'll be back in 1 second, and then we'll probably start a different midterm question or something. I don't know. We'll see. I'll be back in 1 second.
Yo, how y'all feeling about this? I'm kind of lost.
Considering dropping.
Say what?
Considering dropping.
Oh my gosh, I am considering that too, man.
The next semester, the midterm, is
Yeah.
a take-home assignment.
Oh my
You
god.
have 2 weeks to do it, I think.
That's a big temptation right there.
Alright.
Well, ain't nobody say engineering was easy. Wait, do some people not have chapter 5 on the midterm tomorrow, or whenever it is?
Mikhail, like Gervais, I don't think his class does.
Groovets
Oh,
doesn't
because
have chapter 5. It's just 3 and 4.
Tokusoi
do Friday.
has chapter 5, and I'm like, why? That's one more lecture I gotta rewatch now because of
Wait,
that.
so did your did you guys profs like let you pick what days you wanted to do it on?
Yeah.
Because
Wednesday or
No,
Friday.
'cause,
Toxoy didn't.
profs just-
Toxoy didn't
wow.
know, but Gervis does, yeah. Okay, I'm just getting everything that we want to do. So we could do a Toxoy midterm now.
Wait, which midterm was this? From the one that was posted?
This was, I don't know. I don't even know where I got it. I mean, I guess I got it yesterday. But
It was probably one of them, man.
yeah.
Okay, whatever.
I think it's a Gervitz one, yeah.
Okay.
Let's try a Toxoy one. Does that sound good?
Yeah.
Okay. The answers are highlighted, so maybe I want to choose the one with the answers not highlighted at least. And then we can just check the answers after. Oh no, the answers are highlighted even in the one without the solutions, so what's the difference? That's at least the
For
difference.
this question, can you zoom out like
Yes.
to the whole thing?
Well, it's a little too far, isn't it?
Oh.
That's the whole question. Can you see that though?
No.
Okay. Is that any better? That's not the whole question now, though.
Just a tiny bit, and then I'll take 2 pictures.
Okay, zoom in a little more, or?
Yeah.
Then I'll just do like that. So this is the beginning of the question,
Yeah.
and then that's the end of the question. Oh, sorry, there's technically 2 more tests I do. 2 more tests I do, I guess, after. So it's not really the end, but you can see that's between the answer and the answer.
Thanks.
Okay, no problem. Let us try one of these. Did I already take a screenshot? Okay, find the value of x that makes the equivalent annual worth in years 1 through 8 equal to $600 per year. Use an interest rate. Oh, did I miss something? What? Find x. Nope, I didn't. Okay. Use an interest rate of 10% per year. The cash flows in year 0 and year 8 have an unknown value of x, and 1 through 7 have an annual worth of 600. Okay. What I understand is we have 2 different cash flows. Kind of weirdly worded. I don't really understand the wording, but okay. We have 2 cash flows. Both 1 to 8 years. 1, 2, 3, 4, 5, 6, 7, 8. Well, I did that terribly, so try that again.
We have a question.
Yeah.
When we have a cash flow at like year 0, so isn't like 18, like 19 total? Because doesn't it say cash flows from 0 to 8?
Yeah, there's 2 different cash flows happening here. I'm pretty sure there's 2 different cash flows happening here. One of them, one cash flow situation or whatever it's called, is year 1 through 8, $600 per year. So 1, 2, 3, 4, 5, 6, 7, 8. Then the other cash flow is the same thing, but year 0 and year 8 have an unknown value of the same value, and 1 through 7 has an annual worth of 600. But how is that not 600?
So doesn't it mean that like 1 through 7 cancel out? So you would have 1 cash flow at year 1 and 1 cash flow at year 8, both equal to 600. It has to equal 1 cash flow at year 0 and 1 cash flow at year 8 that are X value, and then you just kind of solve for that. I don't know.
I don't know if that. I can't really understand the wording of the question. Let me read it again. Find the value of x that makes the equivalent annual worth in years 1 through 8. Did I miss another part of the question? No, this is question 1.
No, this is the whole question.
So that make equivalent annual worth in years 1 through 8 equal to $600 per year. The annual worth in years 1 through 8. What does annual worth mean? Does the annual payments?
Yeah.
I think that's I think it's like the A. I mean, like A from 1 to 8 equals 600.
Okay.
At 10%.
And then cash flows. So I think what I understand is this is one situation. This is another situation. This is a different situation, and we're trying to find the value of x and make them equivalent. But the thing is that they're all identical, except that in years 0 and 8, there's an unknown payment, but for it to be equivalent, doesn't that just have to be 600? How could that be any number except 600?
Because it's like shifted, because like an extra one in the other one, I guess. Because the second one is from 0 to 8, and the other one.
Oh, this one has an
8.
extra one in year 0. Oh, okay, an extra one in years. I see. So they're not as identical as I thought they were. Okay.
Yeah, them.
5,
Dream
6, 7, 8. Okay, that's one situation. The other situation is almost identical, except that in year 0, we have a payment of x. And then 1, 2, 3, 4, 5, 6, 7, 8. We have payments of $600 through here. So 600, 600, 600, 600, 600, 600, 600, and then another payment of x. So,
Wait, can I tell you how I think we solved it or not?
Well, here, I'll say what I think, and then you'll see if it's the same thing as what you think. So,
okay, perfect.
I'm going to find the present worth of all these cash flows at year 0, and then find the present worth of all these cash flows at year 0 plus x, and that, which would be part of the present worth, and then make them equal and solve for x.
Okay, not quite.
Okay.
So what I was thinking of is, since we know that 1 through 7 for both cases is equal to 600, right? And since it's in the same year, so like 1 from year 1, like that, we can just cancel them all out.
You're right.
So we can bring 8 in the first case back to year 0.
Yeah.
And we can bring the 8 from the second case back to 0.
Well,
and it's gonna be
x to year 0.
Yeah.
But yeah.
Yeah. So
Year
basically
8.
just what you did, but just ignore the 1 through 7 in each cases, because it's just the same thing. It's like 600 at the same year, so we can just ignore them.
That's true.
That's how I thought.
That's true. I'm gonna write it out fully, but then you'll see that they cancel. So it'll be pretty much the same.
Yeah, they cancel.
Yeah, but I'm gonna write it out fully just for clarity. Yeah.
Okay, perfect.
Yeah. So for the first one, let's find the present worth of all those 8 payments. Well, okay, so it won't cancel that well if I do that. Yeah, it won't cancel that well. Okay, what we're suggesting is that, okay, to find the present worth of these payment series, of this one here, of the first one, you're going to do the present worth of that first one is 7 equal payments, so of $600. So 600, P given A, 10% 7, plus another $600, P given F, 10% 8 years. The reason I didn't just do 8 and then forget about this is because now when I find the present worth of this other one, what's the present worth of this other one? Well, it's x plus 600 P given A 10% 7 plus x P given F 10% 8. And when I make these equal to each other, right, 600 P given A 10% 7 plus 600 P given F 10% 8 equals x plus 600 P given A 10% 7 plus x P given F 10% 8. The magic is that those cancel. So we're left with just 600, 600 P given A 10% 8 equals x times 1 plus P given F 10% 8. And so x is 600 P given A 10% 8 over 1 plus P given F 10% 8. So that's why we do it kind of weird. Because
and then you just like compute it and get the right answer, or like whatever.
Well, hopefully get the right answer. Get the right answer is a different step. Compute it is its own step. So yeah, let's see.
Madam, I have trust in you. It's gonna be the right answer.
Okay, let's see. First of all, any.
Wait, I have a question.
Yeah, I was gonna say before I compute it. Any questions?
For the first one, how come you did 600 p given f?
Because I still, even though, so I said here 600 p given a 10% 7. That only accounts for 7 payments.
Okay.
And then I need to account for the 8th payment still. So I just took that 8th payment and moved it back 8 years.
But then why didn't you just do 8 in the first place?
The reason I didn't do that is because then I get this to cancel. I get these two to cancel, right? So I get on this side 7 payments of 600. I also have 7 payments of 600 down here. That's what we noticed.
Yeah.
Right. We also have 7 payments of 600 here. So if I just treat that as a chunk and a chunk, it'll work.
Okay. But you would have gotten the same answer like numerically.
Yes. Numerically, you would get the same answer if you count.
Okay.
Yes. I think again, everything is with an I think. I don't really know that much what I'm talking about when I'm talking about economics, but quite certain that you would get numerically the same answer if you did that. It would just be a little bit more numbers, a little bit more computation you have to do. This just nicely canceled, so that's why we did that. So, so 600 p given a 10% 8. I can find that. P given a 10% 8. Where are we? 18%? No. 10% 8. P given a. P given a 10% 8 is right there. Is that 8? 3 from the bottom. 5.335. So 600 5.335 over 1 plus P given F 10% 8. P given F 10% 8. 0.4665. 0.4665 equals X. So this is 600 times 5.335 over 1 plus 0.4665. So I got 2,000. Ooh, that doesn't look right. $2,182.75, which is not one of the answers. That's also way too much money. Did I punch something in?
I have a question.
Yes.
Like, I don't know if this will help, but can you like try to use 4 decimal places for like the top one? Because like that's like course convention and like I don't know, just better get in the habit of it.
But I don't have any more. I don't have any more decimal places from the table. I don't have any more.
Oh, I don't know. I did. It's like 49 or something like that, wasn't it?
I don't have my table that goes up to this. I don't know.
Okay, I'll take a look for you because I think mine has 4 decimal places. It's like course convention. It's just like good to get in the habit of it.
I understand. Yeah, it is. So maybe the canceling thing didn't work.
Yo, where y'all getting these tables? Can you send it in homework help?
Yes. Okay, sure.
I'm using the same one that Adam's using. And I'm like,
I can't. Then I can't.
Who do you have?
I have Tokusoi.
Okay, I'll send this to you.
Yeah.
Just
Tokusoi is good.
Can you explain the 2 drawings? Cash
flow
drawings?
Yeah. Just to be clear, our answer isn't right, so we made a mistake here. But yes, I can explain the cash flow drawings quickly. So the first one is the purple one that's happening, right? So we have years 1 through 8, $600 per year, 10% interest. So that's what's happening. Year 1 through 8, we get $600. These are each $600 payments, and that's that. That's the first cash flow. Does the first cash flow make sense?
Yeah.
Okay. And then the second cash flow is the cash flow in year 0 and 8 has an unknown value X. So year 0 and 8 have an unknown value X. And 1 through 7 has an annual $600. So these are all $600 still. And that's it.
I found the table and it's 49.
49? Wait. Well,
I sent the table that we used in my class, the one with like 14, 13% and stuff. It's in homework help.
Oh, okay.
It's the one that our teacher gave us.
Well, who do you have?
Thank you so much, buddy.
I can't say his name, but it starts with a G. Guy with the cats.
Gorvitz.
Yeah. His table's pretty good. It has, what does it do? It goes 0.5%. It goes all the way up to
20% by 1. Yeah.
20% by 1, and then after 20%, it goes up by tens. Or no,
Fives,
20,
fives.
25%, 30, 35, 40.
Yeah,
And
I
then
thought
after
so.
40, then it's 10. But yeah. But yeah, his is much better.
So it doesn't make a difference, Adam, right? Like it's barely anything different.
It won't make. That's not the reason we got the wrong answer. Yeah. That's not
Yeah,
the
I know. I'm guessing it might have been that we misinterpreted the question because we can't guess what it meant because we're all like kind of confused.
I have a question.
Yes.
How did you get the 600p given a in the final equation? Like when you did the fraction 600p over a.
Yeah. What do you mean? Like, how did I get this number? 5.3349?
Oh no. Like, shouldn't it be p given f, or am I wrong?
Oh.
Because you split it up, right?
Yep.
To like a p given a. So I thought you would.
Yep.
Like, yeah.
So
I think that's
that should be. Oh yeah. Look, that's an F. Looks like an A.
Yeah.
But that's an F. Okay. Good. P given F. P
Oh,
given
there, yeah.
F. So P given F 10% 8. P given F 10% 8 is the same as on the bottom. Why do both of them have P given? Oh, okay. So this is 0.4665. 600 times 0.4665 over 1 plus 0.4665 is $190. $190.
Okay, that's good.
And is that the answer? Yep, we're good. That's the answer.
It's kind of weird. So wait, it's kind of weird because it's like 3 decimals, so I thought it was like 190,000.
Yeah. I know. I don't know why he writes. He has tenths of cents for some reason, but that's okay. Okay, so there you go.
Yeah.
We did successfully do the question. Any questions about this question?
Wait, can you scroll down to like when you did like p equals that, p equals that? Wait, a bit higher. So for the first one, you split it up into 2 p's because you wanted to be able to cancel out, correct?
Yeah, I split it into 7 equal payments and then another payment at the end.
Yeah, so it's like for cancellation purposes.
Exactly. Because then here again we have 7 equal payments of the same amount at the same interest rate for the same years. So these will cancel which they do here on the red lines. And then I just have to account for that X at the beginning and the X at the end.
All right, perfect. Thank you.
No problem. Okay.
Wait, where do we mess up with the calculation?
This looked like an A, but it's an F.
Oh.
That's all it
Okay.
is. So I did P given A by accident instead of P given F.
It wasn't like a math error. It was more of a writing error. So like the method is perfect. Like use the method, everyone. Like use the method is good. Just like write your A's properly, I guess.
Yes.
Write your F's properly.
That's the lesson to be learned here. Write properly so people can read your writing. Yeah. Let's take a look at the next one, I guess. I have a million things open. Okay, so let's see this next one. Okay. Suppose I borrow $10,000 a day and promise to repay the loan in 2 payments. One in year 2 and one in year 4. Wow. Oh, sorry, not $10,000 a day. $10,000 today. With one in year 4 being only half as large as the one in year 2. At an interest rate of 10% per year, the size of the payment in year 4 must be. Okay. So let's make a cash flow diagram. This isn't too bad of a question. So if I make a cash flow diagram like this, what important dates do we have? Well, we have year 0. I take out a loan for $10,000. Right? I get $10,000 today. Now, I'm paying in 2 payments. One in 2 years and one in 4 years. So 1, 2, well, I should draw it on top. 1, 2, 3, 4. In 2 years, I'm making some payment X. And in 4 years, I'm making some payment X over 2. Because the one in year 4 is only half as large as the one in year 2. At an interest rate of 10% per year, the size of the payment in year 4 must be, essentially, we're solving for X. right? So let's find the present worth of these two payments and make it equal to 10,000. So the present worth of the green side is 10,000. Now the present worth of the red side is, well, it's just x p given f 10%. What was it? 10% 2 years.
Yeah, 10%.
Plus x over 2 p given f 10% 4 years. So 10,000 equals x times p given f 10% 2 plus 1/2 p given f 10% 4. And now I can just solve for x by saying x is equal to 10,000 over p given f 10% 2 plus 1/2 p given f 10% 4. Right? And so we just plug it in. So 10,000 over p given f 10% 2 is 0.8264 plus 1/2 p given f 10% 4. P given f 10% 4 is 0.6830. So 10,000 over 0.8264 plus 0.5 times 0.6830. So I get x is equal to 8,562.4, let's just say, dollars. And the question was, what is the size of the payment in year 4 must be? Well, it's x over 2. So the size of the payment in year 4 is x over 2. That's going to be equal to 8,562.4 over 2. And that's going to be, answer divided by 2 is going to be 4,281.2. And that matches our range. So we're good.
Well, yeah, I have 2 questions.
Yes.
So on the cash flow diagram, does it matter like which way, like does it matter if, for example, you do this, but with like the $10,000 down and with the axis up, or is it as long as you get the direction right, that you should be fine?
As long as you properly account for everything, it should be okay. As long as like they're opposite directions, right? It's okay. Just like if you're doing a free body diagram and you say the force of gravity goes that way, it can, as long as you're, as long as that makes sense, as long as you account for that for the rest of the question, right? It's just like, that's it. So this is just a tool. These diagrams are just a tool, just like the free body diagrams are just a tool to help solve the problem. So yeah, it doesn't really matter how you draw it.
Okay. And also, like, I'm pretty sure, like, it's not, for this question, it doesn't matter. I'm pretty sure when you're doing like f given p and p given f, you're supposed to like do the equation and not the table, because I heard that like I know on some quiz apparently many people messed up because of like rounding.
Yeah.
So like make sure you like do what the course convention is, because it's not, I know like usually in physics it doesn't really matter how you round as long as you keep everything in the calculator, but I know that like on some of the tests you might actually like lose marks because you like didn't round properly.
I see.
So like I'm pretty sure you have to like do 4 when you're taking it from the factor table, and when using p given f for f given p, you're supposed to do like the 1 plus percentage to the power of whatever.
Yeah.
Like I guess that doesn't matter here, but like I don't want anyone.
I see what you mean. I know. Yeah. Let's try to not lose marks for those silly reasons, right? Yeah. So that makes sense. I'll do it like that then. I'll do it like that with it's a very simple formula.
It doesn't matter. I just want to make sure that no one like loses marks for like
Exactly. So do you, any questions about question 2 left that we have? Okay. I'm gonna take a 5-minute break and eat food quickly, and then we'll be going 5-10 minutes just when I'm done eating. So I'll try to eat quickly. And then we'll keep going with this midterm questions after. Okay, so I'll say 10 minutes, but I'll just come back whenever I'm done eating. So back at 7:42, but again, I don't know. Back when less than 10 minutes probably, but I guess I'll say that. Okay, back soon.
So I'm guessing no one here has done the test yet, correct?
I'm doing it on Friday.
Yeah, I have Tokso, so I have to do it on Friday.
I should say the recording is still going, just so you know. The recording is still going.
Clutch at him.
No, but I'm not gonna say. I think saying. I guess you haven't done the test on Monday. I guess you haven't done the test yet. I don't think that's anything fishy.
Nothing fishy, bro.
Yeah, we are good students here, you know.
Yo, what chapter is the guy doing right now?
What?
Oh,
what chapter is he doing?
3?
I think there's 2, no?
No, there's no chapter 2. It's just 3 and 4, and this is 3.
Oh, chapter. Okay. Yeah.
Because I'm pretty sure, like, if it's like those questions, it's like monthly, weekly, daily, mortgages and bonds, then it's like 4. And if it's just like moving things left and right, then it's like 3.
All right. Wait, how far did he get in?
I don't know.
All right.
Bottom is such a nice guy. Like the fact that he's tutoring, like Adam saved my grade. Like I can't thank this guy enough.
The man's amazing. What can I say?
Yeah, I wonder if he's gonna like watch the recording back and he's gonna hear us say, "Adam is a great guy." Like
I don't think he's gonna watch back like 3 hours of economics footage.
No, but what was if once he's like showing his friend like the recording or something, or if he's showing it for a job interview?
Yeah.
Like, he's like, "Oh, hey, I tutor on the side. Look, here's a video," and then it picks like this one, and then it scrolls like some random time in the video. And then it's like us saying, "Yeah, Adam is a great guy. We really like him." I don't
That's
know.
hilarious. You never know when things like that pop up.
Yeah, I already told Adam actually he's a great guy and saved me my grade, but like, I just can't thank this guy enough. Like I don't know, it's just he's my university grade. Like
Yeah. He's just on top of everything, bro. I'm so behind on everything. It's not even funny.
I just can't. Bro, it's COVID. Who's on top of things? Like let's not be kidding ourselves.
Yo, hello.
Yo.
So because I'm just starting to study ECN.
Yeah, same. I haven't done any questions yet, except this.
And I mean, like, I didn't know what's going on this whole year, so I'm just starting right now.
I would say it's not hard until you get to week 4. The hardest part is just wait, whose class do you have? Do you have Tokusa or Gorvitz?
I don't even
know. Go check. Let me know who you have, because if you have Tokusa, I'll let you know the things you want to focus on and the things you don't want to, like, you kind of just want to like ignore.
All right, wait, which is the one that wait, I think I've talked to it, because is Gervis the one that had the test today too?
Yeah.
Okay, that
Yeah.
Yeah, I the other one then.
Okay, so basically, week 1, 2, and 3 are really, really easy. Week 4, it gets a little hard just because it's very hit or miss, right? The wording will mess you up, right? So other than that, it's not too bad. Week 4 is not too bad. Other than the wording will mess you up, and then week 5 is like okay. I would compare it to week 2 and 3, and then week 6 I haven't even done yet, so I can't even let you know. So I would say just zoom through the first 3 weeks.
It's actually so bad.
Wait, what?
Week 6 has the analysis thing. It's so bad.
No, I think it's this course. Like you're very good at it, or you're like not good at it.
Yo, how long does it take to
Good at it. What?
How long does it take to get to like week 4?
4 weeks.
Well, depends. Depends if you depends on how quickly you watch it. I watch it at 2 times speed, so
Yo,
It was
I'm
pretty
not
quick.
gonna watch the thing though. I'm gonna just look at the slides.
No, watch him do the questions.
Yo,
Yeah,
I watched it on 2x speed, so like just zoom through it, my guy.
Yeah.
And plus, it's like 1 hour max for each video. So 6 hours. That's if you are completely focused and you don't watch it at 2x speed. But I would suggest doing it at 2x speed, and you can just pause it whenever you need to do it.
Yeah. Also,
Whatever.
if you want like this extension that I have, which allows you to like make it even faster, so you can like get the extension and then do like a times 2.5 or 3 if you're good.
Wait, how do you do that? How do you do that? How do you do that?
It's a Chrome extension.
Okay, I'm getting it. I'm getting it.
Send me a message so I can like send you the link.
Okay.
Like right now, so I don't forget.
Okay. Profile.
wait, do I have to watch the lecture? Can I just look at the slides? No.
I would say watch lectures.
Honestly, you can just do the slides, and then if you need help, you can look back at the video recordings because that's what I do. Like if you
Alright,
really don't understand.
Alright. So how long's the slides?
Was this you? I sent you the link.
Yeah, it's me. It's me. Got it.
Okay, bless. Okay,
Yo,
that's it. It's right there.
How
Yeah, I
long?
think you do. Wait, let me. Okay, go ahead.
I was saying, how long do you think the slide's gonna take?
It
If
really
you're
depends.
writing all of it down, it's like an hour-ish.
No, not writing it, just doing questions and just looking at the slides and stuff.
It doesn't
Oh,
take
it
that long.
shouldn't take too long.
Alright.
But I
Wait, if you're doing that, it shouldn't take long at all. Yeah.
yeah.
Alright.
Yeah, it depends how fast you learn. Because like if it's something like these things are like, as I said, kind of a hit or miss. It's like if this thing just flows to you, or like it makes pretty much a lot of sense, with some small exceptions, then like it should be very easy.
Oh,
Also,
don't
not
give me false hope like that. Like
what am I supposed to say? Am I supposed to say, oh, you're gonna fail the class, you're gonna fail the course?
You're screwed, bro. Bro, you're screwed. Like, yo, don't even bother even watching lectures, bro. You're just screwed.
Yeah, you just go and just go home and like feel defeated. Be like,
Bro, we're already at home, my guy. We're not in university.
Yo, how far did this guy that's doing the thing, how far did he get into it?
Like an hour.
I'm not sure.
Like half an hour.
I mean, like, in terms of like weeks, or like.
We're doing questions. We're just doing midterm questions right now.
Oh, you
So,
guys,
like, they cover all of them.
You guys should be doing your midterm right now, actually.
Yeah.
What?
You guys, honestly, I would suggest that grab one of the midterms, right, and like time yourself how long it takes you to get it done.
Wait, do they have like current midterms that you're like supposed to do for practice or no? Or just like
Yeah, Tokusoi uploaded some. Like that's where we're getting the questions from, right?
Oh, I didn't know that.
Yeah, so that's where we're getting it from. Today after watching week 6, I'm gonna probably tomorrow I'm gonna time myself doing the midterm and see how long it'll take.
No, because it's charging.
Yeah, it's like I'm actually I'm gonna get the course. Like it's okay. It's whatever. I wonder if Adam is eating and looking at us, or like listening to what we're saying, or if he's just like in a completely different room, having no idea what's going on.
I can bet you he's like sitting right at the desk and he has his headphones on. He's just muted.
Yeah, maybe. Hi, Adam.
What's good, my guy? We weren't talking shit about you. I promise.
He can watch the recording if he doesn't believe us. Recording you.
I magically paused the recording. I mean, what?
No, you hacked it, bro. You hacked.
Yeah,
you hacked the server.
I'm a computer engineer, my guy. I hacked it.
Actually.
Yes.
See, perfect, right there.
Yeah.
Bro, I just play with Legos, to be honest. Civil.
I'm a civil engineer. Hey.
Bro, I'd be playing with a Lego city, for class. They'd be like, "Yo, make this a man has fallen into a river in Lego City."
No, I'd be playing with blocks 2 in Minecraft.
With what?
I'd be playing with blocks 2 in Minecraft.
No, bro, you'd be playing with redstone in Minecraft.
Yeah.
Making that. Okay, good for you, Edward. No one wants to hear. Sorry about that.
I love siblings. I love siblings. They're the best.
Yeah. He's how old are you? 8?
You asking your brother how old he is?
Ah, sure. You don't want to get that accuracy, you have to get the 3 significant digits,
Yeah. You gotta have that uncertainty.
You have to have like 8.56 plus or minus 0.01
Yeah.
years.
Exactly. Precisely.
Yeah. And if not, then you lose 1 mark for improper rounding.
Mm-hmm.
Bro, I had this high school teacher. I remember in not in science, like not in sciences, but in linear, no, not in data management, and like how like in high school there would be like communication.
Yeah. That was so stupid.
Like in her class, you would have like every test you would have like 4 communication marks at most.
Yeah.
And then like she would like take an entire mark off if your fraction line was like too short. If you're like if it was too short and it didn't cover like the entire fraction, she did like an entire mark off.
Yo, you know the most messed up part about the high school like communication part is they'd be like, yo, you need to write your equations on different lines, right? Like you need to like put it in levels, right? The professors in university don't care. They'll literally write it in. They're literally in one line. They'll write like 5 different equal signs.
Yeah,
I'll be like confused. I'm like, bro, what are you writing
That's
down?
true. That's true. Yeah.
All that communication went out the door.
Yeah, or what they do in high school is they fear mongering. They're like, oh, when you're gonna get to university, you know, blah, professors won't do this, or they won't do that, and then you get to uni, and they're like,
they don't even care.
They don't even care. No, you get to uni.
I mean, they don't like chase after you to do assignments, no, but they also are not like these.
No, but I want the communication part of it, where they don't like do the one line one equal sign thing.
No, of course, yeah.
It gets confusing sometimes, but the guys is fine. All right.
Okay, I am back, of course. Hello.
Awesome.
And
No, you're not.
I'm not yet. Give me another 5
The
minutes.
ghost.
Yeah, that's true. I will have to leave for another 1 second in about 5 minutes because Caitlin's
Oh, okay. I predicted it.
Yeah.
You, Adam, did the PS5 delivery came or something?
Yeah. Yes, that's
Yeah,
what's coming
we
in
got
about
PS5?
5 minutes. 5 minutes. I'm gonna have a PS5 delivery. Not actually. No. Okay.
I don't know DHL works this late.
Yeah, that's true. So, question 3. You invest on a very promising project. Suppose that the equivalent annual worth of costs was... Annual worth of the cost were... I don't know. Okay. $125,000 per year for 5 years. The cost in year 1, was $190,000, and the cost decreased by a uniform amount each year over that 5-year period. Okay. However, it did not say how much the decrease was each year. If the interest rate was 20%, the amount of the annual decrease must have been... Okay. So, this is kind of a tricky one, but I can see how we'll do it. So, let's try drawing the two things. So, there's two situations that's happening here. First situation is that we have equivalent annual worth cost was that much per year over a 5-year period. That's our first cash flow diagram. Our second cash flow diagram is this one. Year 1 was that much, and it decreased by a uniform amount over the 5-year period. Okay. So, okay. Let's draw both of our cash flow diagrams. So the first one, what is it, 5-year period? Yeah, so we say year 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Get my phone here. Then we know that there was an equivalent annual cost for 5 years, each amounting to $125,000 for 5 years. Okay. But the actual thing that happened is that in year 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Year 0. In year 1, we have $190,000 payment. So technically these are payments, so they should be going down, but it doesn't really matter. $190,000 payments. And then we have a linear gradient. I assume linear gradient.
Yeah, it's a linear gradient because it's uniform amounts.
Yeah, there you go. So we go like this. So it's less and less we get each year, or we have to pay really each year. Like that. Okay. So essentially, we don't know how much that decreases though. We don't know how much that decreases. Right? So goes down by the same amount each year. So that decrease we'll call x. So that's 2x. So that's 3x. So that's 4x. So let's find the present worth of this first one to begin with. Let's find the present worth at year 0. So the present worth of that first cash flow diagram is P equals 125,000. P given A, 10%, 20%, big interest rate, 20% for, there's 5 payments, so 5 years. Okay, now the present worth of this other one. This is how we do it, I think. Again, everything with asterisks on it that say I think. What we do...
Wait, I think if you want, I can like opinionate on it a bit too.
Tell me what you think of this. Tell me what you think of this.
So I think of it as like you do what you did so far, and then you do a big box that's like 19K from 1 to 5, and then you subtract like a gradient from it, and then basically just something like that.
Yeah. So how we deal with this is, let's find the present. So we're finding the present worth of the second thing here. You can think of it like this. Every year we have a equal payment series of 190,000 every year from 0 to 5. So it starts at 1 and ends at 5. Okay, but every time you have a gradient being subtracted by the amount of x every year. So we can think of it like this. The present worth of this is 190,000. P given A. Let me make sure the recording's working. Yeah, okay, we're good. P given A, 20%, 5 years, again. But we subtract off of it x, P given G, which is the gradient, principal given the gradient, 20%, 5 years. I think this will work. Do we we subtract.
Can't we just do the second term, because it's just P given G?
What do you mean? Sorry, what's just do
like this is the second term where like x is P over G 20 then 5, right? Can't we just do that second term
to find the present worth?
Yeah.
But then you're not taking into account the fact that we have $190,000 to begin with, and we're losing from there, right? So you have to say it's starting from somewhere, and we're losing from something. This only accounts. This here only accounts for the loss.
For the difference.
Here.
Okay. Yeah. Okay. Yeah, then that makes sense. Yeah.
The green accounts for the actual payments. Yeah. So we just set these equal to each other. So 125,000. P given A, 20% 5 equals 190,000. P given A, 20% 5 minus x, P given G, 20% 5. And we just solve for x. So that's just going to be x equals 190,000 P given A, 20% 5 minus 125,000 P given A, 20% 5 all over P given G, 20% 5. And let's see. Sorry. Let's see. 20% is here. We're good. I have it. So 190,000 times P given A 20% 5. 20% P given A 5, 2.991. 2.991 minus 125,000 times P given A 20% 5, which is the same amount, so 2.991, over P given G 20% 5. P given G 20% 5 is 4.906. Okay, I got 39,600 and something. Yep, we're good. There we go. $39,628, which is the range that we want. What did I say? 39,000. Yeah. Okay, it worked. Any questions?
Everything's perfect.
Yeah, did that question make sense? How we did that? Hopefully. Okay, there's no questions. I will carry on, but feel free. And thank you for people who answer the discussions chat for me, because I don't have it open most of the time. But if I need to be pinged, just ping me and I'll see it when I open Discord again. Or you can just unmute too. I don't mind. So, okay, question number 4. Sorry, something caught in my throat. With some water. Okay. I plan to put aside 1% of my yearly income. I expect to make $1 million in the first year, and then I expect my income to increase by 5% each year for the next 6 years. Okay. At the interest rate 10% per year, what is the equivalent annual worth that I plan to put aside in years 1 through 6? Okay. So, okay.
Okay, I think I know. Maybe.
Okay, let's hear what you say.
So I think it's basically a not linear, a geometric gradient, and you just like a million and then up and more, and then you just take whatever a million and the geometric gradient, then you like multiply by or divide by 100 to get like the actual thing you put away, and then you just, you know what I mean? So it's like a million and then a million. Like I guess you can do it manually. Like you can.
I was gonna say. I think you. Do I have to do it manually? Do I have to manually figure out how much you're putting away each year?
Let me.
Because in the first year you put away, million, so 100,000. No.
Or do a geometric gradient on the million and then take the final number and multiply it by, or divide by 100 or something like that.
Yeah, I see what you mean. Because you only want 1% of it. But I don't know if that'll work. I don't know if that'll work because it's 1%, but the fact that we're calculating over 100% of the income would probably change the number.
Why would it? Because it's always, isn't like the entire question just multiply? Like it's, if the entire question, which from the looks of it, it seems like multiplication, then it doesn't matter when you multiply or divide by 100.
Well, it's all multiplication and division if you ignore what's inside the P given A and stuff like that. In there, it's not all multiplication and division.
No, but like that's just one kind of bracket, you know what I mean? It's like a bracket multiplied by bracket multiplied by bracket, and then it doesn't matter when you multiply the brackets together, you know? Or something along those lines. It's like I have an idea.
But if this was if this said 50%, I don't think we could just divide our answer by 2.
Why not?
At the end. I don't think that would work because it's more money. It's a different amount of money that you're dealing with. More money will gain more interest than less money. I don't think it's directly proportional. Because,
or another idea. How about we take the 5% and the 1% and we combine them? Because it's always 1%, it all increases by 5%. Can't you like combine them to like get, I guess, some number, and the geometric gradient is like the number when you combine it. It's like
I see what you mean. Because
if you like,
I don't know how that would work though. Yeah.
Okay.
We don't have a way to. I don't think we have a way to scale that 1% up. Like I get what Irvin's trying to say, where if we scale up the 1% instead of like trying to figure out the value you put aside, like by taking that million and like multiplying it by whatever you need to do to get that 1%. Like, I get that, but I don't quite understand how we would.
I don't see how you'd actually do it. Yeah, I know. Yeah, I see what you mean.
Yeah.
I don't see how you'd actually do it.
Because even if you could, you could just multiply that arbitrary number by 1 million and get the same number that you would if you raised it by 5%.
Yeah, I see.
Yeah, but at the end of the day, couldn't you do this question as like by brute force? Because like you just take 1 million and you do like.
It could be.
Yeah, well, you could do any question by brute force, right? You could just do compound interest for every payment.
No, I know, but I know Gravitz said I think at some point that like sometimes it's better to like do brute force, not because like sometimes if you have like 50 years, for example, it's not good to do brute force because like 50 years of just like things. But I know that Gravitz said that sometimes it's better to do brute force because if you do so, then like because it might take like a longer time to actually figure out the fastest way.
Yeah.
Then like just do brute force. So I think it might be in this case at least it's easier. So I.
Yeah, I would say. Oh, sorry. Hold on. We want 1% of it, so divide by 100. So divide by 100. There we go. So is this also a 5% increase from 10,000 to 10,000? Yeah, that is still a 5% increase. So then the next one would be 1050. 1, 2, 3. No, 1 million. Huh? What? This is supposed to be $1 million. This is supposed to be $1,050,000. Yeah. This is just here. How about this? This is just the amount of money you make, and then we'll only take 1% of everything at the end. Yeah. 1,050,123 times 1.05. So this is. Oh, sorry. This is 1,102,500. This is answer times 1.05. This is 1,157,625. So I get the next one is 1215. Can't see the too dark. 506 point. Well, whatever. 506. Well, okay. 0.25, and then the next one is. Next one is 1,276,281.563. Okay, then we only want 1% of each of these things. So 0.01 times. Yeah, that's right. So this is 10,000. Well, okay, I guess I could have just divided by taking away 2 zeros. Okay, this I can also just take away 2 zeros. This I can also just take away 2 zeros. This I just moved the decimal place here. So I'll just round it to that. Yeah. This, I'll move it. That's fine. I think I can just do that. But yeah. And then this one also, I can just make that a 3. Okay, so that's the amount of money that's being put away each year. Okay. What is the equivalent annual worth that I plan to put aside? Constant payment? Is that what it's asking for? Constant payment?
I think so.
It's asking for a constant payment. Okay, yeah.
Looks like it.
So, well, we can find the. This is still a 5% increase each year. So if I find the present worth of this, it's going to be 10,000 p given a some percent, 10% for 6 years, plus something, which I have to find a formula for. Plus, so I'm looking at geometric gradient for g being positive. G is a positive number, we're going up. So this is the initial payment. Oh, no. So I don't have to account for this. No, I don't have to account for this. No, A1 is 10,000. And then I say 1.1 to the power. There's no like p given something for this. You just have to do it. 1.1 to the power 6 minus 1.05 because it's a 5% increase. I should show what formula I'm using. That's the formula I'm using. I'll put it up there. Okay. So 1.05, because 5% increase to the power of 6, over 1.1 to the power
Your
6.
camera is blocking the formula you just put on. Yeah, there you go.
Thank you.
Yeah, yeah.
And this is 0.1 minus 0.05. Okay. And that's the present worth. Let's calculate the present worth. 10,000 times a fraction, which has 1.1 to the power 6 minus 1.05 to the power 6, 1.1 to the power 6 times 0.1 minus 0.05. Not to the power 6, right? Yeah. So I got a present value of $48,710.2. And in 1 second, we will turn that into an equal payment series. Give me 1 second. I'll be back in like 1 minute. Literally 1 minute. Okay, I'll put it on AFK for another second, but 1 minute. Okay. Okay, we are back. So this is our present worth. I want to turn this into an equal payment series over the next 6 years. So I think I just do A equals 4,800 and what? No, 48,000. That's a 10 there. 48,710.2 times A given P 10%. 6 years. Let's try it. So A equals, I need to find what that is. Uh, 10%, I'm on 20%, not quite. A given P, 10%, 6 years is 0.2296. So 0.2296, so this is 48,710.2 times that, so answer times 0.2296, and I got an error. Times. I got 11,183.9. 11,183.9. And 11,183.9 is in that range, yes. Okay, good. I thought it was 283 for a second. I was like, oh, a little far, but no. Yeah, okay, we're good. There we go. So, how is everybody with this question?
Quick question.
Yeah.
So you got, for the different values for you're actually paying in each year, I'm guessing you took like 5% of the previous year and then calculated what, and added it on to the previous year and calculated what that was like in the future.
And then found 1% of it. So essentially, I started with 1 million. I found, okay, what's a 5% increase? That's the next year. That's the next year. That's the next year. That's the next year. 5% increase each time. And then I went over everything again and just took 1% of each thing.
Okay. Okay. Thank you.
That's kind of a brute force way of doing it. Quite possibly is a nicer way of doing it. I just did like that. Okay. So there's that. How many questions? Oh, there's quite a few questions in this test, so we're not going to run out of questions. So this next one here, Question 5. If there's any questions you have for, or if anybody has questions for like earlier ones we did, I can still answer them. Don't worry. So, yeah. So question 5 is: suppose you borrow $300,000 now at an interest rate of 12% per year compounded monthly, and the rate increases to 15% per year compounded monthly after 6 months. How much will you owe at the end of 1 year? Okay. After 6 months. Okay. So at the end of 1 year, compounded monthly, so we have 12 payment periods that are here. So let me make the cash flow diagram. And that is a tiny cash flow diagram. Make it better. There we go. So month 0, month 1, month 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we borrow $300,000 now. Come on, OneNote. Come on. You can do it. You can do it. Nope, can't do it. Okay. You borrow $300,000 now. $300,000. Okay. At an interest rate of 12% per month compounded monthly. Sorry, 12% per year compounded monthly. After 6 months, it switches to 15%. So let's separate this into 2 different sections, right? So $300,000 now, that compounded monthly. That's this bit here, and then this bit is here. So let's find the future value at 6 months that you have, and then we apply a new interest to that. So what we do is we take the $300,000. So the future value at 6 months is $300,000 F given P, some percent that we don't know yet, 6 payment periods. And then to that value, we apply another F given P, some percent we don't know yet, which will be different than that percent, another 6 periods, and that will be our actual final value. So essentially this is the purple, this is the entire thing. Well, sorry, I should say this is the pink, right? So that purple accounts for $300,000 final given the principal, for a percentage we don't know yet, for 6 payment periods. Applied to that, that will become our new final value here, which will become the principal for this one, right? And so that principal then has another interest rate applied to it for another 6 months, right? So this is that. Hope that makes sense. So now what are those interest rates? Well, I just have to find, okay, so it's compounded monthly, and it's also paid monthly. No, it's just compounded monthly. Never mind. So there's no payment period. So I think I can just do 12% divided by 12 for the first one. So the effective interest rate is 12% over 12, which is 1%. So 1%. And then for the next one, it's the effective rate number 2 is 15% over 12 is some amount of percentages. Let's see. 15 over 12 is 1.25%. So 1.25% is here. Okay. Now we can just find all these values. So F equals 300,000. Now we need F given P 1% 6. 300,000, yeah. F given P 1% 6. That's a 1/4%. I want 1%. F given P 1% 6 is 1.062. Okay, and then I want to multiply that by F given P 1.25%, which I do luckily have 6. F given P 1.25%, 6 is 1.077. And let's see if that works. 300,000 times 1.062 times 1.077. So I get the final amount is 343,132.2, which matches the range. We're good. Okay. Any questions about this question? Luckily, they seem all pretty straightforward so far. They've been okay. Not to say that, it's easy to be confused with ECN, so if you're confused, I'm happy to explain. The fact that I understand just means that I can explain better.
Are we allowed to talk about the questions that were on quiz 2?
I have no
Or
idea.
on the previous quizzes?
Maybe someone here knows if we're allowed to talk about that. Does anybody know? Any admin here?
Well, they gave the solutions to it.
Okay, then most likely yes. I'd say yes.
Okay, so I'm going to send you a screenshot of the question.
Sure.
And the solution in homework help. So you said that there is no payment period, right?
Yeah.
And I was thinking the same thing when I was doing this first question, but they did find a payment period here with n and then k times the number of years. Because k represents the
this is
payment
you
period.
just posted it in homework help. Oh, okay, I see. Sorry. I didn't
homework
see.
help.
Okay, let's see. Let's see. So, future worth F has to be found from a present amount P 5 years from now at an interest rate of 6% compounded monthly. What interest rate must be used in the P given F factor when n is 10? Or F given P factor when n is 10. So they did 6% divided by, they did the compounded monthly, but there was 10 payment periods? No.
I'm not sure. So what I was thinking, right? I'm like, okay, so n we usually use, since it's compounded monthly, it's been 10 months, right? I'm like, but why would that change the interest rate?
That wouldn't change the interest rate.
Yeah, right? So I didn't quite get where they came up with the k value.
Oh, the formula's even different.
Yeah, it was in the lectures, but I don't quite understand how they found a use for it here, because they don't talk about any payment periods or anything like that.
It was in the lecture. That formula was in the lecture notes.
Yeah, that formula was in the lecture, because I have it in my notes.
Let me see if I have it. I don't really.
We have the same teacher as well, Toksoi.
I'm looking at my notes. This is what I have. And it doesn't want to load for some reason.
Can't wait.
Nope. Still doesn't want to load. Come on. Make it smaller. Nope. Download it. Okay. This is what I have for week 4.
It's in week 4, yeah.
Yeah, so week 4 I have this formula for IA, whereas the effective interest rate APY, annual,
Yep.
no.
Mhm.
Oh, that's wrong. That should say annual percentage yield. Oh, no. Effective annual interest rate. It should say effective annual interest rate there. Is that,
and then
that's
right
not the
after
formula.
that.
I have this formula, which is different.
So right there, k is the number of payment periods per year, and to find k, so we first define C to be m over k, right? And then we say that if compounding occurs at the same rate as which the payments are made, we can say n is equal to k times the number of years.
What's m? What's m here?
So m is the number of compounding periods per year, right? So it's compounded monthly, so that's 12, right?
Oh, hold on. Okay, hold on. Yeah, let me.
So we define C as m over k, right? So since we have that ck at the bottom, that's basically just saying m is at the bottom.
Yeah, let me write this down. So you said m is c over k.
I'll send you a screenshot of the notes as well. Boom, boom, boom. It's in homework help.
Okay, yeah, here. Let me take the screenshot here.
I was inspired by you, and I started making LaTeX notes.
Yeah, did you? Very nice, very nice.
They look so nice.
Yeah,
I
they're
like
very
it.
nice. Yeah, exactly. So, okay, so we have. How is this? This is the same formula. It's just written slightly differently, right? Yeah.
Mhm.
Good. So.
But wait, did I include the second part? Yeah, the second part is the part where they include the equation. So if compounding occurs at the same rate, we do the n equals k minus k multiplied by the number of years. I feel like I got it wrong.
I don't really understand. Yeah, I see what you're saying, but I don't understand how exactly. Yeah, how it applies to the question. Because if I saw this question, I would say it's 5 years from now at an interest rate of that compounded monthly. So it's an interest rate of 6% per year compounded monthly. What interest rate must be used in the f given p factor when n is 10? Does that mean 5 years from now is 10 of something? So 10 6-month periods? Is that what they mean? The payment, yeah, that might be what they
10.
mean. Payment periods.
Okay.
Periods is 6 months. That means because
every 6 months.
Because then 10 of those would be 5 years.
Okay.
Right.
Okay.
So and the compounding period is 1 month. So then I just plug that into this formula here. Well, I'll do my formula because I'm more used to it. So this is 1 plus 6% over the number of compounding periods per payment period. So there's 6 compounding periods per payment period times the number of payment periods per year times 2 to the power of the number of compounding periods per payment period, 6 minus 1. So I get 1 plus 0.06 over 12 minus 1. I get 3%.
So that's what they got. So okay, I guess that makes sense.
That's what it is. It's that when n is 10, that means that the 5 years has to be taken in n in 10 periods. Right,
Gotcha.
10 payment periods. So
Gotcha.
there you go.
Okay, that's the part I was overlooking.
Okay, good.
Right. Awesome.
Okay, so let's keep going with the test, the midterm then. This was number 5, yeah. So let's take a look at number 6. Since the session's going well, I think I'll try to make some time in the next few days to do some more because it is good practice. And I do want to do chapter 5 content as well, right? So we'll definitely try to get that done too. So question 6, for your early retirement, you plan to deposit $1,000 per month starting 1 month from now into a fixed rate account that pays 8% per year compounded quarterly. You must know how much will be in the account at the end of 20 years. Note the bank doesn't recognize any payments done in mid-periods and only looks at the account balance at the end of each compounding period. Okay, so how much will be in the account at the end of 20 years? So starting 1 month from now is convenient. So we want the final value, right? We want the final value. So essentially we want $1,000 per month, F given A, some percent we don't know, and how many months is it in 20 years? Well, it's just 20 times 12. And now we need to find our effective rate. So our effective rate, using this formula up here, is 1 plus the nominal rate, 0.08, over, the number of compounding periods per payment period. So let me just be clear here. Compounding periods are quarterly. So I'll say 4 months. Oh, 3 months, sorry. Months. And payment periods, so pay periods, are monthly. So how many compounding periods are in a payment period? A third of a compounding period is in a payment period. So a third times something, it's going to be to the power of a third as well. And now I just need K, which is the number of payment periods in a year. Well, there's 12 in a year.
Are you sure it's not just 4?
For what?
Where for 1.3, because I thought it was number of compounding periods like per year. So if it's quarterly, that means there's 4 compounding periods in a year, not like the amount of months within one.
Well, this is the formula I have, so I stick with this. CK and C goes in. It might be here. Yeah, this might be simpler to use.
Are they different?
Yeah, they're different variables. They're essentially the same thing, but there's different variables. This one has number of compounding periods per year and number of payment periods per year. This one has number of compounding periods per payment period.
Right? Okay, then sorry.
Which is that, but yeah. Don't worry. Okay, so this should work. Let's give it a try. So 1/3. So it is going to be 1 plus 0.08 over 12 over 3. Oops, 12 over 3. Put this in brackets. Minus, calculator's not working, minus 1. So I get 0.662271%. Okay, that's my percentage, so I'm just going to find this percentage, put it in there, 0.662271%. And I think that's it. We just do the formula. So F given A. Just looking if I have F given A copied. Yes, I do. So this is $1,000. 1.00 yeah, 662271 to the power of 20 times 12, which is 240, minus 1, which is going to be, and then over 0.00662271 equals this. So 1,000 times the fraction 1.00662271 to the power of 240 minus 1 over 0.00662271. So I got a final amount of 585,174.3, which is in our range, so we're good. Okay. Did that question make sense?
Just wanted to mention, like, course convention, you would use 0.006623.
1.006623. So I'd end it here. 3.
Yeah, for course convention, yeah.
Why? Because there's the six numbers after the decimal. Oh, 6 significant figures.
Yeah.
I see. Okay, makes sense. So, yeah. Okay, is that good for question 6? Any questions that we have? For question 6. Okay. I think we're good. Let's do a couple more. So, question 7 is find the equal payment series A such that the two cash flows are equivalent at 10% compounded annually. Okay, let's find the present worth of this amount here. See for a second. Okay, yeah, let's find the present worth of this amount here. So well, the present worth of this over here is the present worth is A plus A P given A 10% 5. Right? Because you have a first payment of A, and then you have 5 payments of A. Okay. Present worth here is going to be, well, it's a linear gradient. Nope. it's a linear. Yes, it is a linear gradient.
Yeah, it's a linear
It's
gradient.
a linear
Yes,
gradient. By 50, you go up by 50, then you go up by 100. What?
Yeah, $50. So G
Well,
equals 50.
But that doesn't. No, it's not. It's not. It doesn't go up by 50 each time because then this would be 0, and then this would be 50, and this would be 100, and so it goes. This and this are separate payment series.
Yeah, just do like what I suggest you do is you do a box of A's that are each worth 100 from 2 to 5.
Yeah.
And then you put a triangle on top of that, and then you move the 50 forward once manually. I think that's how the best way to do
But
so.
since this is at year 0, this is already at year 0. I'll just move it to 0. I'll move everything to
0. Oh, that too. My bad. Yeah, that too.
Okay, so yeah, to do that, so that first payment series is going to be okay. So the amount we have at the beginning is -50. Now I got to get this payment series. Well, the green line is a constant payment of 100 from year. Technically, the series is from starts here and ends here, from 1 to 5. Because again, your first payment is always 1 year after the start.
You can also use like how you like. Oh no, never mind. My bad.
Good. P given A, 10. Was it 10%? Yeah, 10% for 1, 2, 3, 4 years, right? 4 years, and then I want to bring that back a year, right? So P given F, 10%. Oops, 10%, 1 year, and now I need that gradient. So the gradient is. See how I'm going to do it. Let me look at my notes for a second here. So the gradient is this. It is not a geometric gradient. It is a linear gradient. And I want the present value of that gradient series. So I'm going to add. So the gradient is $50. And then I'm going to do.
P given G 10%.
Oh, yeah.
Was it 10% 5 or something?
10%. I think it's
5 or 6.
It's 10% 5 because 4 put it at 1.
I think it's 10% 4. Because
no, but the one in the front costs like the one.
4 put it at 1.
The what? Right.
Well, don't you have to include the first one too? Because you can't like start at 0, so isn't it like from 0 to like it doesn't start at like 50 in some sense. It starts at like 0 if that makes sense.
Yeah, so this is the start of everything, right? This is the start date. So the first additional thing is here. So it's a 4-year series.
Yeah, I think it might be 4 years. Yeah.
Let's try it. If we get it wrong, I'll try 5 years. I think it's 4 years though. So I'm gonna set this. Oh, sorry, and then I also want to bring it back 1 year. P given F, 10% 1 year. Right? And then I'm going to just set these two things equal to each other. So it's going to be A times 1 plus P given A, 10% 5 equals -50 plus 100. Oh, just copy and paste this. Just copy and paste all this. What's that? Oh, I guess I should have copied and pasted everything, but whatever. Add that underneath, and then so A, I'll write it nicely this time. A is equal to -50 plus 100 P given A, 10% 4 P given F, 10% 1 plus 50 P given G, 10% 4 P given F, 10% 1. All over 1 plus P given A, 10% 5. Okay. So I will get all these numbers. Let's see. Table, we're at 10%. So let me scroll to 10%, I mean 6%. Okay, 10%. So first thing is Negative 50 plus 100. P given A 10% 4. P given A 10% 4 is 3.17. There's a 0 after it, but whatever. P given F 10% 1. P given F 10% 1 is 0.9091. Plus 50. P given G 10% 4. P given G 10% 4 is 4.378. P given F 10% 1 is the same thing, 0.9091. All over 1 plus P given A 10% 5. Where's P given A? P given A 10% 5 is 3.791. P given A 10% 5 is 3.791, yeah. And let's see. So negative 50 plus 100. You know what I'll do? I'll add more brackets to this so that I can trust it a little bit more. So negative 50 plus 100 times 3.17 times 0.9091 plus 50 times 4.378 times 0.9091 all over 1 plus 3.791. I get $91.25. Yep, we're good. A equals $91.25. There you go. Something to remember about these linear gradient series is that, see here, this is our first time that the $50 is actually being added. It is 2 years after our present, what we call the present, right? And then we moved it back 1 year as well. But when we're calculating the present worth, it'll bring it 2 years before that first payment.
Bro, that exam is foul. Whoever has Gervitz.
Yeah.
That was foul. I just finished.
Oh yeah, yeah. Was it?
Foul? Which question? I
Bro,
mean,
it's not
yeah,
foul.
it was.
It's not so bad. It's just, let's say all the hard questions from the previous exams. Like there's only one easy question, which is the rate conversion. The rest take a long time. There's a pretty difficult mortgage question.
Yeah, definitely.
That's pretty foul.
The mortgage and the lemonade. The lemonade one was cursed.
Oh yeah. The lemonade
Wait,
one took a
like you did it now?
Huh?
Yeah, we just
They
finished.
just did
I
it.
came
Yeah.
to say hi.
Remember,
and
this
then,
is being recorded also, just so you know,
Yeah.
so we're not breaking any policy. But yes, hi. Hi, bud. How's it going?
I just have a question. I just hopped on. Where's the recording being posted?
You'll see it in tutor announcements on the server, like the one of the first things on the server. If you scroll all the way to the top, third thing from the top, tutor announcements. That's where I post all the links.
Tutor.
As well as the PDFs of the documents that we're doing.
Yeah, I like the encouragement for the test.
Yeah.
Thank you. Yeah. Wait, how many questions in total, or like?
It was a very hard exam, Erwin. Very.
Fuck my life.
Oh my god.
I think that's joking or not. Like, are you guys joking?
It's 10 questions and 1 bonus.
Bro, it was literally like running to the wire getting that stuff in. I had 1 minute to spare. It was holy crap.
Yeah. Really.
Wait, is it all 10? Is it all 10 questions on the same page?
Yeah, it's 10
You can go back and forth. Yeah.
Okay.
All 10 and the bonus.
Oh, the encourage. So it's like.
Sorry
11.
for disrupting, Adam.
Don't worry. We're here to talk about econ, so.
It's like it's that bad. No, not joke. It's actually that bad.
It's kind of bad.
Don't underestimate the power of an engineer. Okay. We're gonna destroy it. Okay. We'll single-handedly flunk the entire thing so we get a curve.
Yeah.
Yeah.
No, we just remember zero on is gonna get power curve to 100.
We win either way.
Basically, the best way to put it is forget about the bonus. That's it. That's the best way to put it.
Oh, is that it? Oh, okay.
That's, if you're thinking about the bonus, just forget about it. Like,
I'll tell you. Can I say this? Okay, bonus isn't really calculation. It's more like theory. I don't know if that's been said though.
Yeah,
Or
but
you
it's
can
like,
calculate it,
at least like putting a random answer, so at least you might not get.
Oh yeah,
point.
you can guess it. It's like a 1 in 4 chance, but
Yeah, I like that. I like those chances.
Like we can't really give away too much because they're all gonna be different. It's just like just just make sure you know what to do in each situation. That's the thing.
Yeah, you got Adam here. I think I'm good.
Guess so.
Can
I
I
don't know if I'm
just
good,
ask-
but yeah, go for it. Sorry.
Can I Can I just ask a question about the previous question, just very
Yes,
briefly?
of course.
So you were moving all the payments to time 1 or time 0?
Time 0.
Time 0. Okay, so since you were moving them, the gradient payments back in time, for the P over F 10%, 1, that bit?
Yeah.
Is it, when you move it back in time, shouldn't it be divided by that instead of multiplied by that, or is that just?
So you're right. If this was F given P, then yeah, you divide by it. But P given F is effectively the same thing. Or what did I say?
Oh, okay.
P given F. We're asking what's the present value given the final value, which is 1 over F given P. 1 over F given P.
Oh, okay.
Does that make sense?
Just
So you would divide instead, yeah.
Yeah, so if it was F given P, it'd be dividing, but it's same difference.
It's the exact same thing, yeah. It's the exact same thing.
Yeah, and this is just a very brief question. If I know I'm cutting it down to the wire, but if I wanted to arrange a tutoring session with someone tomorrow for this, is that possible?
Oh, well, I mean, like, you mean like as like a session, a live session, or as a private?
Just private, like one-on-one.
Well, you can always message me and I can try to help you out as much as I can. But you can also talk to anybody else that's labeled a tutor on the server. There's some other people. It's not on the sidebar anymore. It used to be on the sidebar. But you can message me and I can try to help you find some other tutors on the server that could help you out as well.
Okay, and
Yo,
it's not
Mary, if you want, I can try to help you out. Like, I'm not an expert. I'm not a tutor. Yeah, like I'm supposed to study for it too. So like an excuse to actually study for it is a good excuse, you know?
Yeah, because I'm actually in 2nd year and I'm doing this course now. So like, and I have like so many midterms, and this got put on the back burner.
I'm sure. Yes, it is on the back burner for a lot of people. Yeah, it's not the focus. So just message me after, and I can try to help you out. I'll help you find other tutors that you can ask questions to as well. Okay.
Okay, thank you.
So yeah, I'll be working on this for the next 2 days, pretty much. This, yeah.
I say, yeah. So we.
Yeah.
So we're going to the next question. I understand
Yeah.
this. We're going to the next question, right?
Okay, next question. Yes. Let's do like 2 more questions, and then that'll be it for today. Okay. So you have just purchased 100 shares of XYZ stock at $60 per share. You will sell the stock when its market price has doubled. If you expect the stock price to increase 20% per year, how long do you anticipate to wait before selling the stock? Okay. So we have 100 shares of. Okay, so at the end, we're gonna have a final value of 100 times 120, right? Because we'll have 100 shares of $120 stock because it's twice of 60. So, so this is 12000. So $12,000. That's gonna be our final value. Okay, so we know that our present. Hold on, let me see. $20 per.
Just looking at it, right? Since we know it's compound interest, some intuition would tell us that it's going to be less than 5 years, right?
No, can't you just do the thing where it's like?
No, if it was simple interest, that would be 5 years exactly, right? But since it's compounded, it gets money quicker. That means it'd be less than 5 years.
Yeah.
So we're looking at either B or D, right?
Oh, okay. I think I know how to do it. Can I?
Yeah, go for it.
Sure.
So basically, what we have to do is we just do final, which is 12,000, equals whatever 6,000, and then times 1 plus 20% to the power of n is n.
Yeah, which is F given P.
Yeah.
20% n, right? And we just solve for n. Let me just think about this for a second. The final amount is going to be 12,000. The initial amount is 6,000. The final, given the principal, is what we're looking for, is the interest rate is 20%. So the rate of increase is 20% here. And we're there for n years. So so we just do 12,000 equals 6,000. F given P 20% is 1 plus 0.2 to the power n. Right? So this is going to be 12 equals 6, 1.2 to the power n.
Isn't it 2?
Where? Oh,
like the answer is. No, I mean, why is it 12 equals 6? Isn't it 2 equals? My
Now
bad.
it is. Now it is. Now it is. Yeah, exactly. I didn't get rid of the 6 here yet, right? So it's just divide both sides by 6. Yeah, and then it's just going to be, well, I can just do
Log base 1.2.
Log base 1.2 of 2 equals n. So log base 1.2 of 2 is 3.8. So n is 3.8, so 3.8 years. So it'll be 3.8 years. Okay, how's everybody with this question?
Basically, like I suggest for everyone to do is like the fact that it's a stock. Like, don't try to think of it as a stock. Like, I know it might look a bit scary if it's a stock. Just try to think of it as money. So maybe like if you think, oh, you have this much money, and also since it's 100 shares, everything gets multiplied by 100. But you can also think of just one stock. So you can be like, how much does it take for one stock to double?
Yeah.
You can think how much does it take if you have 60. Basically, you can think of it as how much does it take if you have $60 and the interest is 20% for it to increase to 120. And just try to think of it as money and don't think of it as 100 stocks, think of it as one stocks, and hopefully that helps.
There you go. There's everyone's advice. All right. Very nice. Well, let's keep
I don't even know if this helps anyone, but I'm
something. Yeah. That's all right.
Yeah,
Don't,
something.
don't worry. Don't worry. Okay, this will be our last question for today. Okay, number 9. So and everybody look out on tutor announcements. I'll put there if there's more information about another tutoring session that I will do, or if I will do specifically one for chapter 5 in Toksoy's class. I quite possibly will, because I have to do that. So question 9, future worth f has to be, well, this is essentially our question from before, which we calculated. Is it exactly this question? What did we get, 3%? Yeah, this is the exact question. So I'm gonna skip this. This is exactly the question that I think Vikram sent me. Yes. So let's skip this. Whoop, that's Steam. Let's look at this. So at what rate of interest compounded annually will an investment double itself in 5 years? Okay, this isn't too bad. So the final amount is 2 times the principal amount. So 2p equals p f given p I 5. So 2 equals f given p is 1 plus I to the power 5. So the fifth root of 2 minus 1 equals I. So fifth root of 2 minus 1, so I got 15%. 15%, which is the answer. Okay, let's do another one after that. That was a little too easy. Let's see this. Well, it says simple interest, so maybe this one will be easy too. If I deposit 10,000 at 10% per year simple interest, what compound interest rate would yield the same amount of money in 3 years? We don't know how long the simple interest is compounded for.
Wait, what exactly is simple interest? Like, I heard of it, but what exactly is it again? Could you like tell us?
Yes, I'll find my note on it. So simple interest is no compounding here.
Isn't it like, simple interest where like it just grows, but like, it only grows on like that 10,000 no matter like, so like 10,000, 10,000, 10,000. It's not like it doesn't take into account
You
what
only get interest on the principal amount that you put in there, right? So here, this is what I have about simple interest. In order to calculate simple interest, which is interest that is only applied to the initial amount, use the following. So the final amount is just, this is compound interest. So this is the simple interest formulas. So P times 1 plus IN. So I guess what interest? So we want the final amount. Yeah. It would same amount in 3 years. Okay. So we want the final, let's get the final amount, the final value, final worth or whatever of both of these things. So the final worth of the first one is, the final worth of the first one with a simple interest is just going to be 10,000 1.1 to the power 3 for 3 years. No. Yes, I guess. Okay, that's fine. Then the final amount for the compound interest is going to be 1,000 or the 10,000. What interest rate? So 1 plus I to the power 3. Is that how it works? Wait.
I think you used the compounding one for both.
Yes, I did. Yes. So this is 1 plus 0.1 times 3. And then this is that. So we make those equal to each other. So 1 plus 0.3 equals 1 plus I to the power 3. So 1.3, so the cube root of 1.3 minus 1 equals I. Let's see. Cube root of 1.3 minus 1 equals I. So I got 9%. And that is correct. There we go. Okay. Okay, everybody. Well, we ended on a couple easy ones there, but hopefully today the 2 study sessions were useful. Definitely useful for me. I got to practice all these things.
Can you go back to question 9?
Before everybody starts leaving, tomorrow I have my MTH 240 session, which is at 6 o'clock, of course, for our mini test. And again, look out in tutor announcements for any more econ stuff, because I'm going to be working on econ a lot in the next few days, so maybe I'll do more sessions. We'll see. But anyways, yes, good luck, everybody, with all your work, and have a good night. And now I'm here for some questions. Yes, Erwin.
Wait, did we do question 9? I feel like I wasn't paying attention for like a second. Did we just skip over it?
Question 9 we skipped because that was Vikram's question right here.
Okay, because I just turned around and then
we skipped it. Yes, we skipped it because it was exactly the same.
Do you have like notes for like this? Just like the same way you have notes for like 240?
Yeah, it's in homework help. Look at pinned. Go to homework help and look at pinned. Yeah. First thing in pinned.
Okay.
That's my update. It doesn't have. Are you in Toxoy or are you in Gerbils?
I mean Gerbils.
Okay, so you don't have to worry. I was gonna say I don't have any chapter 5 stuff, but you don't have to worry about chapter 5.
No, but isn't it the same for everybody? I don't think it's the same for everyone.
We have chapter 5. Toxoy has chapter 5 in the test.
Oh, maybe. I don't.
You guys don't.
Yeah, I actually.
Wait, Adam.
Send it to me.
So you haven't watched watched lectures for chapter 5 yet? Because I haven't either.
I have not watched the lectures for chapter 5 at all.
I haven't either.
Started reading the slides and they don't make very much sense to me. So, yes, I will do that in the next couple of days. So look out, Vikram, and we'll probably do some.
All right, awesome, sounds good. All right, later.
Okay, see, have a good night. Have a good night. See